robotic waiter's job is in its name, a robot who takes orders and serves food to customers in a restaurant, and although these waiters typically don't accept orders, they can deliver food to customers and remove dirty dishes. But drawbacks may occur, as many robotic waiters cannot work on their own and need staff assistance. They must take the order themselves, inform the system where the specific table is, and load the dishes onto the robot.
In this video, with Dina, Naomi, and Hamzini, we have designed and constructed our own mechatronic system of a robotic waiter, with the aim of making the robot travel to each table successfully. The purpose of creating a robotic waiter is to replace human waiters, as the robot would be more accurate knowing with the exact table to go to, and would be more hygienic compared to human waiters. We are using the Edison robot in order to do this.
So in this video, we will discuss the different designs and tests we conducted and have chosen, and the numerous failures and successes we've had. We'll elaborate on the planning process we had before designing the system. Then, we'll explain the different designs of the robot's path, the process of writing the code, and the construction of the robot's design.
System environment explanation. Dina did most of the designing for the system environment, ensuring it contained the appropriate devices for the project and the overall aesthetics of the system. Unfortunately, due to accidental circumstances, the first 2 to 3 attempts were deleted, but fortunately, we still have enough progress to record. Initially, the first environment relied on grid tracking for the robot, but we soon opted for a line tracking system instead for convenience. We also numbered the tables. We altered the route of the environment to make it easier for the robot to turn and navigate. Finally, we perfected the tables and we had a finished design.
Coding explanation. Naomi took initiative in writing the code on the EdPy app, which was a difficult task since we didn't know much about coding. When first started, we thought the line tracking program would work best, but we changed our mind as it was too complicated. And hence, we changed our code to simply tell Edison to go either left, right, or forward. In addition, we wrote the return trip as well, so Edison would go back to the station where it would collect dishes. After we got the foundation code, we tried to write an input code, which is when the system will literally ask which table to go to, and the human staff, it will input a table number so the robot will know where to go. To do this, we had to define each section of code. For example, defining the robot going to table 1 as go table 1. However, when we finished, we discovered that EdPy didn't have the input function, so we had to scrap the idea. Therefore, we stayed with our previous idea, letting Edison travel to each and every table automatically, and then waiting for a few moments before traveling again. We even added a sound effect when reaching its destination to add more character.
Model systems explanation. Hamzini was leading the model systems, including designing and building the robot. However, it was a whole team effort to choose which designs were most efficient for the robot. We started by sketching out a few rough drafts of the robot digital, and eventually came to a conclusion that we would select design 1, or the design with multiple layers. This design was chosen as it could hold a lot of food and had a steady/stable design. We made another digital sketch of the robot. Then, we built the first prototype of the robot using Lego bricks. However, we soon realized that we had to adjust the design with more bricks, as it just didn't seem to be fitting as well as we imagined. In turn, a 3D design was made on Tinkercad in an effort to visualize it better. We ended up extending the red wall of the robot. After constantly editing it, we finally decided on the specific design. Finally, we built the last prototype using Lego bricks, including an extra detail on the top, a spinning plate. This prototype was our finalized design, therefore finishing the model system component of this project.
In conclusion, our first build of a robotic waiter was filled with many mishaps, but it was an overall success as it could properly travel around the system environment while still having a durable design. We are satisfied with our project and hope to continue improving in the future in the robotic engineering field. Yeah, I think that actually went well.